Homogeneous reaction is a reaction where products and reactants are in the same phase. For example, if we have N2O4 gas in equilibrium with 2 moles of NO2 gas, so since the reactants and product are in the same phase, okay, so this reaction is a homogeneous reaction, while the heterogeneous reaction is a reaction where the products and reactants are in the different phase. For example, if we have calcium carbonate solid in equilibrium with calcium oxide solid and also carbon dioxide gas, so since the reactants and the product here, we have one gaseous phase and two solid phase here, so this reaction is called as a heterogeneous reaction. So determine whether the following reactions are homogeneous or heterogeneous. For the first reaction, we have aqueous phase, and also aqueous phase. So since all these three substances are in the same phase, this reaction is a homogeneous reaction. Okay, for the second reaction, we have gas, and also gas phase. Okay, so same phase for the reactants and product. So again, this one is also a homogeneous reaction. For the third reaction, okay, so we have a liquid, gas, and liquid. So one of the substance here got different phase. Okay, so this reaction is a heterogeneous reaction. K is the equilibrium constant. So if we have the Kp here, the Kp expression indicates the pressure. So the expression will be in pressure terms. For the Kc, okay, so C here indicates the concentration, right? So we have the equilibrium constant in concentration and also the equilibrium constant in pressure. For the Kp, the only phase that will be included in this expression is gas, while for the Kc expression, we have the gas phase and also the aqueous phase that will be included in the Kc expression. So for this reaction, okay, to write the Kp expression, okay, so we have the Kp expression here. We are going to use a round bracket and then the partial pressure symbol. Okay, so the expression will become the product to the power of its coefficient over the reactants to the power of its coefficient. So since the reactants and also the product got gas phase, so all of the substance will be included in the Kp expression. So the partial pressure of the gas C, okay, so the small letter here indicates the stoichiometric coefficient. Okay, we have the stoichiometric coefficient. Okay, so the partial pressure of the gas C to the power of its coefficient times with the partial pressure of gas D to the power of its coefficient divided by partial pressure of gas A to the power of its coefficient times with partial pressure of gas B to the power of its coefficient. So this is the Kp expression in terms of pressure, okay, for this reaction. For the Kc expression, okay, in terms of concentration, we are going to use a square bracket. So again, product to the power of its coefficient divided by the reactants to the power of its coefficient. Okay, so since we have the gas phase, okay, so the gas phase is included in the Kc expression. So the concentration of the C to the power of C times with concentration of D to the power of D divided by concentration of A, okay, to the power of A times with concentration of B to the power of B. Since the concentration of the pure liquids and pure solid does not change, so it has a constant concentration, therefore it does not appear in the equilibrium constant expression. Let's have a look at example on how to write the Kp and Kc expression. So for this question, write the Kc and Kp expression if applicable for the following reversible reaction. Okay, for the first reaction, so we have aqueous, aqueous, and aqueous. Okay, so since there is no gas, okay, present in this reaction, so this reaction will not have the Kp expression because the Kp expression, okay, the one that will be included in the Kp expression in terms of pressure is only gas. While for the Kc expression, we have gas and aqueous. Okay, so for the first reaction here, we only have the Kc expression. So the Kc expression for this reaction is equals to, okay, product. Okay, the product is H plus to the power of 1, okay, because we have 1 moles here, okay, times with F minus, okay, to the power of 1 divided by concentration of HF also to the power of 1, okay. So for the second reaction, okay, we have gas, gas, and gas, okay, for the Kp expression for this reaction, okay, so since we have gas, so we have the Kp expression, okay, which is partial pressure of the NO2 gas, okay, so 2 moles of NO2, so to the power of 2 divided by partial pressure of the NO gas, okay, 2 moles of NO gas to the power of 2 times with partial pressure of oxygen gas to the power of 1. Okay, and then the Kc expression, so again we have the gas here, gas phase, okay, so the concentration of NO2 to the power of 2 divided by concentration of NO to the power of 2 times with concentration of O2 to the power of 1. For the last equation, okay, so we have liquid, gas, and liquid. So only gas will be included in the Kc and the Kp expression. So for the Kp expression, okay, so we have product over reactants. So since there is no gas in the product, so we put 1 over partial pressure of our reactants SO3, okay, to the power of 1, okay, but and also for the Kc, okay, so there is no aqueous or gas in the product, so again 1 over the concentration of our reactants SO3 to the power of 1.